Then guys, the topic for today is to write two-step equations. I'm going to write in here the topic, write two-step equations. Then in the other part, what we have in the example number 1. I'm going to move in here so you can see the topic better, okay? So in the example number 1, we have to write a two-step equation, okay? We need to write the equation depending on the facts they give you, okay? So we need to write the equation. And what says the exercise states? They are asking you what equation can be used to represent the number of golf balls in Marley's and Tucker's collection, okay? They ask you this, and you see the picture. Marley collection is one basket with golf balls, okay? In the other collection you have is for Tucker's collection. There are 159 golf balls. He has two baskets. They state in the problem that Tucker has more than twice Marley's golf ball collection. Okay. What means this information? What does this information means? Tucker has more than twice, because he has twice and 3 more golf balls, okay? So in the diagram, if you see the diagram that we have below, we can use this bar diagram to represent the situation. So for Tucker's collection, we have 159 golf balls, okay? So M is representing the golf balls in Marley's collection because I think that they use the variable M to represent Marley's, okay? And the number 3 is more golf balls, okay? 3 more golf balls, okay? So we can use the bar diagram that we already have to write the equation. So the information that we have to write the equation is that this is Tucker's collection. And this is going to be equal twice Marley's collection. Plus the number of golf balls that we have additional, okay? More golf balls. Okay then. So we have that the equation that we are going to write is only to substitute, okay? Replace the values that we have in the space, okay? For this. For example, for Tucker's collection, what is the number that we are going to replace? We are going to replace 159, right? This is going to be equal twice Marley's collection. Twice, we are talking about 2 times Marley's collection that is going to be represented by the variable M. So 2M plus more golf balls. The golf balls that we have additional, they are 3. Okay, so the equation 159 equal to M plus 3 can be used to represent Marley's and Tucker's golf ball collection, okay? So you can see the information that the book gives you is that you are going to use to find the equation. For example, Tucker's collection is 159. Twice Marley's collection, 2 times M, plus 3 that are the more golf balls. Okay, so what we can say about this? This is representing the situation about the balls for Tucker's collection and Marley's collection. So it's only to use one equation to represent, okay, what is happening. For example, if you want to find the number of in Marley's collection, you can isolate the variable M. Remember, 3 is addition, so you can pass it to subtract, and 2 that is multiply, and you can pass it to divide, okay? In the book, they don't ask you to do this, but also you need to, you know how to do it, okay? So if you want, you can do it, but we don't need it in this case. The idea, what I'm trying to say is that, okay, if you want, you can do it, because in the other examples, we are going to need it, okay? So having the equation, we need to find maybe some facts, okay, in the future, okay? So now we are going to the other example that we have, that is this one. It's not example, it's supposed that you need to solve it, but I'm going to help you with this. So I'm going to write in the same form that you have it on the book. The cost is going to be equal one blank space plus another blank space multiplied by the monthly payment. Okay. Then, guys, we need to replace. So we need to read the exercise to understand what is going to ask. Okay. What information they are going to ask. So Cole buys a new laptop for $335. He makes a down payment of $50. So the original cost that he's going to pay is $335. He makes a down payment of $50. Okay, so in the moment that he buys the laptop, he pays $50. And later he is going to pay equal amounts of money each month. Okay, a monthly payment in 6 months. 6 months. Okay. So what equation represents the relationship between the cost of the laptop and Cole's payment? For example, the cost equal, I'm going to write it like appears in the book in the number of lines that you need to complete. What amount are we going to write in here? 50, because they are the $50 that he pays in the first moment that he buys the laptop. Multiplied by the monthly payment, what number are we going to write in here? 6, because they are 6 equal monthly payment, okay? And then in the second line, what is the cost? 335, okay? This is going to be equal $50 again, plus 6 times the monthly payment, okay? So 6 times, and we can use the variable P to represent, okay, the payment for each month, the monthly payment. So at the end, we have that 335 is going to be equal 50 plus 6P. Okay, can we check if this is correct? Combines me. Why are both multiplication and addition used in the equation that represents Cole a monthly payment? Why are we going to use the multiplication and the addition? In this case, for example, the addition is because he paid this amount of money in the first month, but it's not completed the payment. So he needs to continue paying more, okay, in 6 months. So 6 times more, he is going to pay one amount of money that I don't know, the variable P, okay? You can find it later if you need it, but in this moment, they are not asking you to find, okay, the monthly payment. Okay, and it's multiplying because this is going to happen 6 times. You are going to pay this amount of money 6 times. Then we can start with the example number 2. In the example number 2, we need to write more two-step equations. You have that a baseball, okay, weighs 25.75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of the weight of the box W. I'm talking about a baseball, okay? A ball, guys. I'm talking about a ball. And the bat is the bat that they use to play baseball. So, for example, what we have in the information, we have one box that contains 50 bats and weighs W ounces. So one baseball weighs 5.25 ounces. So we have the comparison between the baseball and the bat. We write the equation: weight of one baseball this is going to be equal the weight of one bat minus the difference. Remember that a baseball weight 25.75 less than a bat. So if you have less than, it's because it's going to be a subtraction, okay? So less than difference in weight. Okay. So for the example 2, the weight of one baseball. What is the weight for one baseball? They give you the 5.25. This is going to be equal to the weight of one bat. The weight of one bat, but remember that inside the box, there are more than one bat. There are a lot of bat, okay? So we are going to divide the weight of the box by the number of bats. The number of bats, they are 50, okay? So we divide by the weight of box by the number of bats in box. I'm going to write it below because we don't have space enough. Okay, minus the difference in weight, and y is, what number are we going to write in the difference? 25.75, minus 25.75, okay? This is the difference that we have in here. Then we can interpret this equation, and they give you the information that the weight of box is going to be W divided by the number of bats in the box, that is going to be 50 bats, okay? Minus the difference is 25.75, minus 25.75, okay? So this is the information that we have for the first one. And if we interpret the equation, we say that the equation 5.25 equal find over 50, W, I don't know why I write in here 5 is the variable W, okay, minus 25.75. This can be used to represent the relationship between the weights of a baseball and a bat, okay? So depending on the number of bats that you have inside the box in this case, okay? So this is for the example number 2. We only write the line that we have. And we can go to the example number 3. The example number 3 is only to interpret quantities and operations in equations. Okay, so Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off. Okay, so $3 off, we are talking about a discount, right? If we let X be the original cost of each ticket, which of the following equations correctly represents this situation? So you need to identify what equation is going to represent the situation that you have in this example. Okay, so we have 3 possible equations. 3 multiplied by x minus 8. The other one is 8x minus 3. And the last one is 8 times x minus 3. And all of them are equal 104, 104, and 104, okay? So this is what we have, and we can interpret one by one. The first one, $3 of discount times the difference of 8 tickets and the cost per ticket. X, remember, is the original price for the tickets. $3 are the discount. So if you have the original price of the tickets minus 8, you are not having a discount of $3. You are discounting $8, okay? So you are losing more in here. So this is not, because she only buys 3 tickets. You know that she buys 8 tickets, so the answer could be this one or this one. So we need to find what is more convenient. 8 tickets multiplied by the original price, okay? You are going to obtain one amount of money, and you only subtract $3. For everything, you only subtracted $3. So this is not our answer, because the $3 of discount is for each one of the tickets. So we have the original price, we subtract $3 for each one, and we multiply because they are $8, 8 tickets, sorry, 8 tickets. And this is going to be equal $104. So this represents the situation because we have 8 tickets times the difference of the cost per ticket and $3 more of discount, okay? So guys, I think that I'm going to finish in here recording the class, okay? I'm going to finish.